Hello everyone, welcome back to my YouTube channel Namaste AI. In today's tutorial, we are going to build a multi-container application using Docker Compose. So far, you have learned how to run individual Docker containers, but in real-world applications, which are never just one container, those applications involve multiple containers. A modern app usually has a front end, a backend API, and a database. All those files run as a separate servers or separate services. Running all of these manually in separate terminals is very painful. Imagine there are several those files or services for your particular app running, and it is very painful if you manually run those individually on separate terminals on your computer, and getting them talk to each other is even harder. That is exactly what Docker Compose solves. You define all your services in one file called docker-compose.yml file, and then you can start the entire application with the one single command. By the end of this video, you will have a full working student portal application, which is the application I am using in this demo class or tutorial. That student portal would be running in three Docker containers. The front end will call the backend. The backend will read and write to PostgreSQL database. All started with one command and all stopped with one command. Let's go. Before we write a single line of code, let me show you on my screen. It is visible. Let me show on my screen what we are building today. Okay, so we have, as you can see, we have three containers. Container one is the front end. It serves our HTML file, which is the dashboard file, right? The CSS structure file for the HTML and a JavaScript. Nginx runs inside this container, and it delivers the web page to your browser. Okay. Container number two is the backend. It is a Python Flask API. It handles requests from the front end. It runs SQL queries and returns the JSON data or in JSON format. Container number three is the database, right? We are using in this demonstration, we are using PostgreSQL 16. It stores all student records permanently using a Docker volume. Okay, this Docker volume. The browser talks to the front end on port number 8080. Okay. The front end proxies API calls to the backend, and the backend queries the database. All three containers live on the same private Docker network called portal network. Here is the key concept. Inside that network, containers find each other by service name. The backend does not need the database IP address. It just connects to a host called DB, and Docker resolves it automatically. This is called service discovery. So let's build this. Okay, we minimize this. So I created a project folder, Docker Compose student portal, on my desktop, and I want to open that folder in my VS Code. I open this VS Code application. Let me adjust my appearance of my screen. Let's zoom in so that you can see clearly. Okay, so as I mentioned, I have created a folder, Docker Compose student portal. It has three files: the backend, the front end, and Docker Compose. Okay. So So in the backend, I have two files saved. The first is the main application file in Python. Okay, so app.py file. Okay, this is my app.py file, and then I have a Docker file, and then I have a requirements. Okay, what packages I am running today in this demo for this particular project. So yeah, the requirements, I am using Flask, Flask cores, psychopg2 binary. Okay, Flask is our web frame, and Flask cores is it allows the front end to call the back end without browser security errors, and psychopg2 binary is the PostgreSQL driver for Python. Okay, uh, for app.py file, this is the heart of our backend. Okay, this so the main purpose of this demo is to show you how different containers interact with each other for your particular application using Docker Compose. So I'm not trying to explain every single line of a code in this demo. However, I will show you main things. Okay, for example, the two things I want you to notice here. Okay, the first thing is the 4 environment variables, right? And you can see here on my screen, which are db host, database host, db name, db user, db password. Okay, these are not hard code values. They come from Docker Compose at runtime. So this is the correct way to handle configuration in containers. Never hard code credentials, always use environment variables. Okay, I'm not using any hard code passcode, password, or things like that. The second thing is the init database, this function, or this retry loop in this function, define init database. Okay, so this is the retry loop, 10 times, its range is 10, it runs for 10 times, and it has a time step function 2 seconds. Okay, so it tries to connect to PostgreSQL up to 10 times. So this is what it means. Okay, and wait for 2 seconds between each attempt. PostgreSQL takes a few seconds to fully initialize after the container starts. Without this retry, the backend would crash immediately, trying to connect to a database that is not ready yet. Now, the backend Docker file. Okay, so this is the backend Docker file. So notice we copy the requirements.txt file here first and run pip install, and then copy the rest of the code, and this is the Docker layer caching trick. Okay, yeah, first I want to run this, copy. Okay, in my console terminal, I want to oops, okay, I think I already installed that packages, so never mind, I can run this pip install. Okay, so pip 3 pip, okay, so I'm running those packages. Okay, pip install. Okay, so let me see, pip3 install this. Okay, so I use pip upgrade pip new release. Okay, never mind. I think before I start recording, I already run those commands. Okay, so now the front end, right? This is the back end we discussed, and for front end, we have this index HTML file, right? And I have a JavaScript file, right? And yeah, in the JavaScript file, I wanna make sure one thing. So in this JavaScript file, the most important line is the very first line, right? Constant API URL, this API. Okay, this is just a path, not a full URL. The browser sends this request to the same host it loads from, localhost 8080, right? Nginx inside the front-end container receives it, and it sees that API path and proxies it internally to the Flask backend container. The browser never talks to the backend directly, and this also means we never expose the backend port on your machine. It only reachable inside the Docker network. And now the Nginx configuration. This is my Nginx configuration, and this is what makes the API proxy work. Okay, and three locations blocks. Three location blocks. The first serves our HTML, right? The first serves our HTML. Yeah, this one, this first location, and then the second location API, and then I have third location, this this first location HTML, and this is the second JavaScript CSS. The third is the API, right? As I mentioned, the first serves our HTML, the second tells the browser never to cache JavaScript or the CSS file. This prevents the state script.javascript issue we will talk about in troubleshooting or maybe in a later video. The third proxy is any request starting with the API to the backend container on port 5000, right? This is my port 5000 for that API. Docker DNS resolves backend to the backend container automatically. Okay, the front end Docker file is just 4 lines. If you see, this is the Docker file, it has just 4 lines. Okay, the Nginx Alpine version, which is lightweight version, and this is the path to my local machine for that HTML Nginx database, right? And this is the default configuration path, and this is a port 80, exposed to port 80, right? And then moving on to my Docker Compose. So this is the most important file in the entire project. Everything else builds individual containers. This file wires all of them together. Okay. So let me explain few things about it. Okay, so in services, each entry under services is one container. We have 3 services: database, backend, and front end. These names become host names on the Docker network. Okay, and then the health check on database. Where is my health check on database? This is the health check on my database, right? So this is critical, and it has timeout. It has interval for 5 seconds and timeout every 5 seconds, and it retrieves 10 entries, right? And then I have a database host. DB host is DB, student name student DB, user Postgres, password, okay. Um, the front end port is 8080, right? And then the volume is a student data. Okay, so this is my Docker Compose file. So let me do one thing. In my VS Code terminal, I wanna compose that my containers. So docker compose up build. So I am building up my this Docker Compose file. Okay, looks like those 3 containers have been created. Let me go to my Docker desktop, and you see this 3 containers: front end, backend, and Postgres, right? These 3 containers or images. And in under container, the same thing. It run on individual ports. So front end, student front end, I have this port 8080, and then a student backend, and then student database. So if I open this port, which is a local host, so let me open in incognito mode. I want to open in incognito mode. Okay, so let me open this, Control V, hit this. Okay, and view, so I can zoom in, right? So view, zoom in, view, zoom in. Okay, and I want to enter my name. Let's say before recording this video, I entered my name as a student name, and I added a course name, okay, in the database. Let me add another name. Let's say Ankur Kapoor. Course name is chemistry. Okay, add. So this second student is added into the database. Ankur Kapoor, course is chemistry. I can add third student. Let's say Michael. Course name is let's say physics. Add. Okay, so you see it. So all 3 containers are running. I wanna try, right? I wanna try few things. So let's minimize this, open my clear my terminal. Okay, so if I wanna see my 3 containers are running or not, I wanna run this command docker this ps. Oh, because I stopped the container. Yeah, so let's see. Yeah, I stopped the container. Yeah, and I can start back again. Start. Okay, if I run the command again, see, so I have 3 containers, right? Front end, student backend, and student database. All of 3 are running. Okay, and look at the ports, right? Yeah, actually minimize this. Never mind. Yeah, this port I was talking about, right? Yeah. View appearance, zoom out. Yeah, these ports, port 8080, right? For front end, 5000 for back end, 5432 for database. Okay. So I have shown you the browser in this demo, localhost 8080. I have shown you that this, okay, it's working, and I have shown you I can add different student names, their course names in the database. It is getting saved without any error. Okay. And let's check the network and logs from the terminal. Okay, we can also check that. For that I can write docker compose logs backend. Okay, so I can check that log, right? And you can see every get post requests, every get and post request the backend received logged in real time, right? Yeah. And this is how you debug a Docker Compose application in production. You can just simply run that command, Docker Compose logs backend, and you can debug your Compose application in production. If I want to see the network, how containers communicate, I can run docker network list. So these are the networks, okay? And you see the portal network that is making all the communication possible. The scope for that is local, and the driver is the bridge, right? Docker Compose created this when we ran Docker Compose up. So let's inspect that. We can also inspect it, okay? For that I can do docker network inspect docker compose student portal network. Okay, so docker network inspect docker compose a student. Am I using the correct file? Docker compose a student portal, docker compose student portal. Oh, something is wrong here. So let me copy my this code. I think there is some error in typing. So portal, okay, portal network. Okay, I don't know why it is not showing up. I don't know. Let's try another command, docker volume list. Okay, so this is the volume, and you see the student data. This is our persistent volume. Okay, if you stop the volume, delete the containers right now and recreate them, the same thing that we did in our previous demo class, where we created the volume. Even though if we delete our containers, the data would still be there. Okay, so yeah, that's about it. I can shut down my compose, docker compose down. Okay, it stopped and removed my containers, student front end, student back end, and student database. And if I check my desktop, it's gone. Docker desktop, it's gone. Okay, yeah, and I can delete them from here. Delete. Okay, So that the project example I showed you today, it's gone after I entered this docker compose down. Okay, so it stop all the 3 containers and remove the portal network, and your student data volume is still there. So data is safe. Even though I remove the container, data is safe. Okay, data is safe. So yeah, and I can show you again. I can compose it back it again. So docker compose build no cache docker compose build. So I can create the backend, front end, student backend, student front end database back again. Yeah, you see, it's live again. You see, it's activated again. Student portal front end, student portal backend, right? So yeah. So yeah, I think that's about it. So in today's demo, we built a complete multi-container application using Docker Compose. I have shown you 3 services, 1 command, front end served by Nginx, backend powered by Flask, data stored in PostgreSQL, and all connected on a private Docker network. And here are the four things I want you to take away from this video. First is Docker Compose is one file and one command. You define all your services in Docker Compose and start everything with Docker Compose up dash build with that command. Number 2, containers on the same network find each other by service name. DB host equals DB. That is the Docker's built-in DNS. It's not a magic, okay? Number 3, always use depends on with the condition service health for databases. Not just depends on, use depends on with service condition, service healthy. Okay. Number 4, volumes. The named volumes keep your data alive. Docker Compose down is safe. Docker Compose down -v deletes everything. In the next video, I will show you how to add CI/CD to this project using a GitHub actions. Automatically it builds and tests every time you push your code. Stay tuned for that. If this tutorial helped you, hit the like button. It genuinely helps the channel. Subscribe for more Docker, DevOps and AI engineering content. I will try to do once a week. Okay, so drop a comment below. What are you going to build with Docker Compose? Let me know. I read every single comment. Namaste. See you in the next one. Thank you so much.